Hi, my name is Michal Szynkiewicz, and I'm from the front-end team at Red Hat. I'll be talking today about cloud-native development with MicroProfile on Kubernetes. I have only 35 minutes, so I'll be quite fast. So I'll be later around the Red Hat booth. So if you have any questions or if I went too fast through something, just catch me there. To give some context, I will start on microservices. So you all heard about microservices. They're all about splitting your system into relatively small, isolated services with well-defined responsibilities. And the idea is to have a small team around the service, a small team that is able to design it, develop it, test it, and deploy it. With that, you give developers a chance to choose the technology they want. They can faster test what they work on because they have smaller code base. They can deploy it independently, so it's easier to maintain such thing because you can apply some hotfix on one service only, and you can also scale it independently. So the bottom line is, with this architecture, you should get a faster development. So you should be able to add new features to your system or new components faster. But it all comes at a cost. So first of all, you have much more deployments because all the services have to be deployed somehow. So you basically need continuous deployment for that. If you want to be able to add new components to your system easily, you need some infrastructure that will allow you to add resources easily to the infrastructure. There's more network communication, so you have to be prepared for that, for any problems with networking. And it also becomes more difficult to monitor such system. A part of the answer for these problems is the cloud. So it is a on-demand infrastructure where you can add resources easily, a cloud like EC2, for example. But it doesn't address all the problems. Yeah. So we have some understanding what the cloud is. Now, what does cloud native mean? When I first heard this term, I was thinking about writing C code for the cloud, but it's not that. Cloud native is about working in a way and developing applications that are meant to be run in the cloud. So on one hand, it is about the DevOps side, like the continuous development, deployment, etc. But also about making sure your application will behave well in the clouds. So be tolerant for network failures, be easy to monitor, etc. Okay, I could talk much more about that, but let's go a bit further. So on top of the cloud, you can have a something like Kubernetes or OpenShift. Actually, OpenShift is a implementation of Kubernetes that will help you handling the deployment side of your applications. So with Kubernetes, you can have some quite easy to read deployment descriptors that would allow you to specify how your application should be deployed, in how many replicas should it be deployed, how to redeploy your application. And the basic concept, the basic unit of Kubernetes is a pod. Pod can consist of one or more containers. What you have, pod is generally a place where you would put a single microservice. You can have multiple pods, multiple replicas of such pod. If you want to expose something from the pod within the cluster, you need to define a service. And if you want to deploy something out of the cluster, you can use, for example, an OpenShift route or an ingress, or there's some Kubernetes stuff as well for that. If you want to play with Kubernetes locally, there's Minikube for that. If you want to use the OpenShift flavor, there's minishift that you can use. Okay. So I talked a bit about the deployment stuff around this cloud native concept. Now let's get to the coding side. This is where MicroProfile comes in. So this is the part where your application has to address this monitoring, etc. So MicroProfile is an initiative to define some specifications to help develop applications for microservices, to help develop cloud-native applications. Currently, it consists of specifications for JSON marshalling and non-marshalling. This is JSON B and JSON P, for dependency injection, CDI, for exposing RESTful APIs, and for consuming them. This is the REST client. And also for securing your applications, and you can do it with JSON Web Token. I will probably be able to demo that. There's also a specification for making your application fault tolerant, to configure it easily, to provide some metrics, to expose documentation for your REST APIs, for distributed tracing, and for checking the health state of your app. Let me jump to the demo. Who of you have been on my first talk yesterday about Thorntail and MicroProfile? So not many, okay. So briefly go through what I have here. Let me. Okay. So to demo some of these concepts, I wrote a simple two applications. One is serving quotes, and has a single resource for that. It's a JAX-RS resource, so it exposes quotes and /quotes endpoint, and you can get them, and you will get 3 random quotes from quotes provider. These are stored locally, and you will get a single advertisement on top of the quotes, just to make money on the application. Yeah, and this getting advertisement. Let me show you what's returned from that first, and then go into further details. Call.json is just a wrapper on curl I wrote that adds some JSON headers and pretty prints the JSON. Yeah. So as you can see, I got an advertisement, and then I got 3 quotes from my service. So as I said, the quotes are from some local file here, but the ads are from a different service. I have an ads service, and sorry, I can show you what it returns here. Okay, this is the ad service. Oh, PyR is the lucky one. Okay, so this is that. I use MicroProfile REST client to connect to the service. With MicroProfile REST client, you just write an interface like you would do for exposing the JAX-RS endpoint, and then you can create a, let's call it a stub from the interface that is able to talk to the service behind it. So I used REST client builder. You can also do it with annotations. So I just created a builder, then I provided some URL on which the ad service is available, and then I said that I want to build the client from the ad client interface, the interface that I just showed. This ad service URL, I injected it with CDI, it's here, and I'm doing it with MicroProfile config. This config property annotation is from MicroProfile config. And MicroProfile config first checks in, actually not first, but you can provide values for MicroProfile config, for example, through MicroProfile properties files that you put in metainf in your resources, and I did that. So here's that, and that was enough to connect to the add service. Okay, now I'd like to take this application and deploy it to my Kubernetes, actually to OpenShift, but I try to use Kubernetes only commands for that, for everything. And I will also, when it will be getting deployed, I will also go through the POM file for my application. Maybe I'll do it here so that you can see the command. Okay, so I'm using Fabricate Maven plugin for deployment. Let me jump to the POM. So what I have here is a Maven application. So this is how you write a Thorntail application in Maven. So you have to set the war packaging for your project. Are the letters too small? No? Ah, okay. Then you can specify a BOM file that will bring you the versions for all the elements that you want to pick. And with Thorntail, you are able to pick the elements of Thorntail that you want just with specifying Maven dependencies. So I picked JAX-RS, CDI, Undertow, MicroProfile REST client, and MicroProfile Conflict. And what I also had to add to make it work locally is a Thorntail Maven plugin. And with that, when I finish my Maven build with MVN clean package, I am getting a fat jar with the Thorntail elements inside and with my application inside. What I added more to be able to deploy it to Kubernetes is the Fabricate Maven plugin. Fabricate Maven plugin has a generator for Thorntail. What I'm using is Thorntail v2, so I use Thorntail v2 here. For some reason, I have to exclude web app to make it work. This is in the documentation, so I don't know. It should be already deployed. Yep, let's check it. This is how you can list the active pods in Kubernetes. So we have quotes running. This is what you can do to get the logs. If you want to follow the logs, it's like with tail, you just add -f or -f. So yeah, the letters are quite big, so the log doesn't look well, but at the end we have Thorntails ready. What I wanted to show you now is one thing, one more thing. So I have the application deployed there, but Kubernetes is able to figure out when an application is not behaving well and restart such application in that case. But to be able to use this feature, you have to define some probes for your application. So I just wanted to show you that I don't have it right now. So let me use kubectl describe pod for that and grep for example, liveness here. Oops, grep. So there's no liveness check at the moment. With MicroProfile, it's really, and that Thorntail and this Fabricate Maven plugin is it's really easy to add the liveness check and readiness check for your application. It's just enough to drop in MicroProfile health. So, oh, I was doing it here. So let's do it here once again. With MicroProfile health, application application starts to expose another endpoint, is /health, and this it is a basic health check for an application. You can add your own health checks. It's quite easy to do that, but I won't be showing it today. But just dropping it here is enough for Fabricate Maven plugin and OpenShift to figure out that there is a health check that it can use for liveness and readiness. So let's check how it goes. It's still deploying. Do you have any questions in the meantime? Nope. Okay. I never know if it's bad or good. Okay. Let me. Okay. So it should be already running. Oh no, it will be deploying now. Okay. Okay. So it's starting, but it's not ready yet. There's the 0 here. Well, let's see if it already knows there's this liveness check, for example. Oh, it's not the spot, sorry. Oh, okay. The pod has been killed. I think Kubernetes figured out that there has been a change in this liveness and readiness probes, and it will redeploy it again, adding these checks. So it will take a bit more time. Okay. This one, yeah, true. No, I cannot. No, sorry. Cubes. If you use OpenShift, you can use OC instead of kubectl. It's basically the same, but has some additional features. Okay, it's running already. So let's grab it for the liveness. Yeah, here it is. So there is a liveness check, and it should be the same with readiness. So it was enough to just add MicroProfile health to my application to get that. I think it's quite cool. Okay, so we have this application in Kubernetes. I already deployed the ads application to Kubernetes before. So let's query it, maybe. What do you think? Let's first find the root on which our application is available. So let's do kubectl describe root and grab quotes from that. So this is the root for quotes. And the endpoint was rest quotes. Oh, internal flavor error. Do you know why it failed? It failed because when handling this request, I'm trying to talk to the ad service, and the ad service URL that I have defined, it's still localhost, and the ad service is not there. So I'll fix that in a moment, but first I'd like to make my application tolerant for such things as unavailable ad service. So let me add MicroProfile fault tolerance for that. Here it is. Again, I just added a dependency in the POM. And as it happens, I already have a mock add method that I will use. Let's first define a timeout for it, because we don't want users to wait very long time for his quotes in case of failing ad service. It's not a crucial functionality. So let's make a timeout of 1 second. And let's fall back. These are all MicroProfile fault tolerance annotations. Let's fall back to the mock add method if it fails. So I just say fallback method is mock add. Okay. let me restart it. Okay, this was dead. And I will show a bit more. In the meantime, I will talk a bit more about other possibilities here. So what we could also define is a retry. With retry, the MicroProfile fault tolerance will retry calling this method defined number of times. You can also specify a delay between reattempts. You can also make the reattempts have some random delay. It's done with jitter. You can, with retry, you can retry on some specific exception, and you can also say that it should abort on some other exception. This is retry. There's also a circuit breaker. There's also blockhead for that, for in fault tolerance. It's okay. It's still deploying. With, for example, with circuit breaker, you can specify the threshold on which it's called a failure ratio. You can specify a failure ratio that would say, for example, that if there are at least 30% of failures in last 10 requests, like that, then we should not retry calling this method for some time. And this time is also specified. I think this is delay. Yeah, probably. So you can specify how long the method call should not be reattempted, and then after this time, the service would try to call this method again, and if it succeeds, the success threshold number of times. So you can say that if it succeeds only one time, then we should treat the method as something we should run again. Or you can say that it should be 10, the success threshold. After the success threshold number of times, the method will be called again normally. By normally, I mean that when we have less successful calls than that, then every failure would be treated as reaching the failure ratio before. So there will be this delay applied again. So it should be deployed already. Oh, again, sorry. So let's try calling quotes again. Okay, so we got the quotes, and we got an advertisement telling us about keeping an eye on what's coming in Thorntail v4. And as you can see, this is the mocked ad here. So this method call was not successful, and the fallback method was used. Okay, now let's get back to fixing the connection between the quote service and the ad service. In Kubernetes, there is a concept of a config map that you can use to provide configurations for your applications. This is how it looks. Actually, I could remove the namespace from that. Okay, so you just say that you have a config map with some specific name. You can add some tags to it probably as well. And there's data for a config map. Let me add this config map to the application. Let me do it here again. So I will just create a resource from what I have in this file. This was that. And the config map is created. So now I have the ad service URL in the config map, and I have my application getting this value from some MicroProfile config stuff. Fortunately, with MicroProfile config, I can, for example, use environment variables to get such values. So, and yeah, as you saw, it was just enough to add Fabricate Maven plugin to deploy my application to Kubernetes or OpenShift. But I can also customize such deployment, and I will be doing just that. So what I'm doing here is I'm specifying an environment from my for my service, and I'm saying that the environment should be taken from a config map called quotes config. Okay, so let me redeploy it again. So I don't know if it's clear for you what's going on here. So no, 3. So there's some in Kubernetes. There's something called config map, and you can use this config map to configure pods or your services in Kubernetes. And there are several ways of providing values from a config map to a pod. You can put these values in some file, for example, but you can also put them all into environment variables in a pod. And I'm doing just that here. I'm taking the values from the config map with such name. So this is how Kubernetes know which config map I mean. And I'm saying that I want environment from this config map. And MicroProfile config works this way, that by default, by default is not maybe the right expression, but it takes values from MicroProfile config properties. But you can override these values with environment variables or with Java system properties. So you can run your application with -d add service URL, and you can override this value that was specified either in the config properties or here or in the environment variable. So I have this add service URL. I'm injecting it here in the add retriever, and I'm building a client that is using that to connect to the add service. It should be deployed. So let's check if it works. Oh, maybe it's not deployed yet. It should be running. Oh, yep, we got a advertisement about Thorndale, not about Thorndale before, so our application is connected. Actually, I can even get to the pod to show you that the add service URL is here in the environment variable is here. So yeah, and this was picked up by my application. Okay, so do you have any questions for that? No. There's one more thing I wanted to show you, and it will be on the add service. So the quote service only returns stuff, but the add service also has a possibility to add an advertisement. I'm using annotations to secure it, so that not everyone can add stuff there. So there's a get method that everyone can invoke, and it's done with permit all. And there's a post method that is only for an admin. It works with MicroProfile JSON Web Token. I don't think I already were told what the JSON Web Token is. So this is a concept where you can send a token with things like username, user roles, etc. And this token will be signed by a trusted authority. And every service can have a public key of the signing authority, so it is able to verify the token without going to the authentication server. So if you have plenty of services, it should be much faster than just doing the trip there. I already configured ads with that, so I added the MicroProfile JWT fraction here, and unfortunately there is some service-specific configuration required here. So I have, yeah, so there's that. I don't really want to go through that. Sorry. I have already generated a token for that. So let me try if it works. Here's that. Okay, let me steal the URL from quotes and modify it. So it will be ads, and I will be sending data this time. And an advertisement has content and URL. So let the content be EclipseCon rocks, and URL EclipseCon org, I think it is. Maybe HTTP would be nice. Okay, so let's try to add it like that. Oh, I'm not authorized, but I kind of expected that. So I need to add the JWT token or JOT token, and this is how I do it. I add authorization. Actually, maybe I will just cut the token and copy it. I had it somewhere here. Oh, here it is. I will add the token in the authorization header for this request. So let me add it here. Authorization. It will be a bearer token with this value, and it should work. Yep, I think it worked. Let me add a couple of more, and let's query for an ad. So we should get this ad eventually. Yara. Oh, here it is. Okay. That's actually all I have. I put this demo on GitHub. Here's a short link for that. If you're interested in Thorntail, so Thorntail is an implementation of MicroProfile, but it also has, for example, Java EE bits inside if you want to pick them. But it has much more than that. For example, some camel stuff. There is a link for Google group for Thorntail. We usually are on Thorntail channel on Freenode on IRC if you want to catch us. Our implementation of MicroProfile is based on what we do in SmallRye. So here are the links to SmallRye. If you're interested in MicroProfile itself, so here's the page for MicroProfile, Google group for that. There's a MicroProfile ebook that you can freely download here. And there's also a calendar where you can check where the events like weekly meetings or weekly meetings of groups that are working on specific specifications are. So you're free to join such meetings if you're interested in that. It's a community-driven thing, and you can catch me on Twitter. I'm not tweeting much. Okay. That's all I have. Do you have any questions? Still no questions. Yeah. Sorry. Yeah. Let's maybe take this one offline because it's recorded. So the session is recorded. So I don't want to go into details about why I'm using IntelliJ and not Eclipse on a recorded session. Okay. Thank you.